Today our objective is to be able to find solutions to a quadratic equation by choosing the best method. This is day 2 of chapter 9, section 5. So today we're going to look at different quadratic equations and we're going to determine the best solution. There are 4 different methods that we have used to solve quadratic equations. The most recent one was the quadratic formula. We've also learned how to solve by taking the square root. We've also learned how to solve by graphing. When we graphed, the solutions are the x-intercepts, or where the parabola crosses the x-axis. One we've used it's been a while since we've used it, is factoring. If we can get our quadratic equation to factor, that would be a good method to use. So graphing is good if you have a graphing calculator. We're not going to use a graphing calculator, so we're not going to choose graphing. Square roots, we can use square roots if there is no x term. So if we just have an x to the second and we don't have an x, a middle term, it would be good to use square roots. Use factoring if you can get your equation to factor easily. If you've tried factoring for a minute or so and you can't get it to factor, move to the quadratic formula. The quadratic formula always works. It just takes a little longer than factoring if you can get it to factor. So we're going to look at these 4 equations and we're going to decide which method we would use to solve these equations. If you look at number 1, there is no x term. It's just a 3x to the second. So I would use square roots. All you would have to do is isolate the x to the second by adding 1 and then dividing by 3 and then taking the square root of both sides. So then you would take the square root. Looking at number 2, I do have an x term, so I cannot use square roots. I wouldn't use graphing because I'm not using a graphing calculator, so I either have to try to factor or use the quadratic formula. So I'm going to try to factor and see if that works. Let me see, what can I multiply to get x to the second? That would be an x times x. What multiplies to negative 6? That adds to negative 1. Let me see, 3 times 2 is 6. If I took a negative 3 times a positive 2, I would get a negative 6. Outside would give me 2x. Inside, when I do FOIL, would give me negative 3x. That would add to a negative x. So I can get this one to factor. And then from there, what I would do is set x minus 3 equal to 0, x plus 2 equal to 0, and solve each equation. So if I solve this one, I would get x equals 3. Here, if I took away 2, I would get x equals negative 2. So factoring is a little faster than quadratic formula. If you can get it to factor, try factoring. If I look at number 3, I don't want to use square roots because I have a middle term x. So I could try to factor. I would try for a minute or so. If factoring doesn't work, I would move to the quadratic formula. So if I try to factor here, let's see, I've got a 2x and an x. What can I multiply to get 9? Well, 3 times 3 or 9 times 1. But it has to be negative 9, so one's positive, one's negative. So if I tried negative 3 and positive 3, let's see, the outside would give me negative 6, the inside would give me positive 3. That's not going to add to a negative 7. What if I tried 9 and 1? So let's see, if I go back here, I know one has to be negative and one has to be positive. So if I did negative 9 here to give me negative 9x, and I did plus 1, the outside would give me a positive 2x. This would add to a negative 7x. I could use factoring. That would be the best method. And then to finish it, I would say 2x minus 9 equals 0, or x plus 1 equals 0, and solve both of those equations. So factoring is the best method here. Notice on number 4, there's no x term, so we should use square roots. All we would have to do is divide by 5 to get x to the second by itself, and then take the square root of both sides. All right, so now we're going to actually solve. So if you look at number 5, it says use any method, round to the nearest hundredth if necessary. Well, I cannot do square roots because I have a middle term x. So I don't want to graph because I don't have a graphing calculator. So I'm going to try factoring for a minute. Let's see, what can I multiply to get x to the second? That would be an x times x. What multiplies to positive 36 that adds to negative 12? Well, if it multiplies to positive 36, these both have to be plus or both have to be minus. But since it adds to a negative 12, they both have to be minus. Let's see, 6 times 6 is 36. And negative 6 and negative 6 make negative 12, so that would work. I'm noticing the binomials are the same, so that means I'm only going to have one solution. I'm just going to say x minus 6 must equal 0. I'm going to solve that equation. My answer is x equals 6. If I was graphing, there would only be one x-intercept. The parabola would only cross the x-axis in one place, and that place would be 6, 0. So that means the vertex would be on the x-axis. All right, if we look at number 6, we're going to try to factor. I can't use square roots because there's a middle term of x. So I'm going to try for a minute to factor and see if this works. I know 3x times x is 3x to the second. What can I multiply to get a 5? 5 and 1. It's a positive 5, so they both have to be plus or both have to be minus. But it adds to a negative 1. But if I make them both minus, outside would give me negative 3, inside would give me negative 5. If I switch it around and put the 1 here and the 5 here, that's still not going to give me a negative 1. I'm going to have negative 15 and negative 1. So this is not going to factor. So I'm going to use the quadratic formula. When we use the quadratic formula, it has to be set equal to 0. It is. I know a is 3, b is negative 1, and c is 5. All right, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, if b is negative 1, that would be a positive 1, plus or minus the square root of b squared, that would be negative 1 squared, minus 4 times a is 3, times c, which is 5. And then I'm going to put that all over 2 times a, so 2 times 3. All right, so if I simplify this, under the radical I have a negative 1 squared. That's going to be a positive 1. Then I have minus 4 times 3, 12 times 5 is 60. 1 minus 60 is negative 59. I cannot take the square root of a negative, so this is going to be no solution. This is going to be all over 6, but that 6 really doesn't matter because I have the square root of negative 59. So what that means if I was graphing is the parabola would not cross the x-axis. We would not have any x-intercepts. There would be no solution. All right, looking at number 7. Which method would be best? You're right, there's no x term, so I would use square roots. So what I would do is I would add 24 to both sides to get 8x squared equals 33, then divide by 8. So I would get x squared equals, let's see, if I use my calculator and do 33 divided by 8, I would get a 4.125. Then I would take the square root of both sides. I'm going to round to the hundredths place. So x would equal positive and negative 2.03. All right, looking at number 8, I'm trying to determine the best method. I could not use square roots because I have an x term. So if I cannot use square roots, I either have to factor or use the quadratic formula. If I was using the quadratic formula, A would be 1, B would be 4, and C, there's no constant here, would be 0. And I could do that, but I could also factor on this one. I could factor by factoring out the greatest common factor. X goes into x to the second, and x goes into 4x. So I could factor out an x, and I would have an x times x plus 4 equals 0. Then I could set each of these equal to 0. So I'd have an x equals 0, and x plus 4 equals 0. Here's one solution. The second equation, I would have to take away 4 to get x equals negative 4. So x equals 0, or x equals negative 4. If I use the quadratic formula, I would get the same two answers. All right, looking at number 9. I'm going to try to factor first, because if I can factor, it's going to be simpler. I know I can't use square roots because I have an x term, and I don't want to use graphing. So if I try to factor, let's see, x times x is x squared. What can I multiply to get 11 that adds to 5? Well, 11's prime, it's only 11 times 1. The outside would be 1x, the inside would be 11x. That's not going to give me a 5x. So I'm going to have to use the quadratic formula on this one. I know a would be 1, because I have 1x squared. B would be 5. C would be 11. All right, so negative b. B is 5, so that would be negative 5, plus or minus the square root of b squared, which was 5 squared, minus 4 times a is 1, times c is 11, all over 2a, 2 times 1. All right, so if I simplify what's under the radical here, 5 squared is 25, minus 4 times 1 is 4, 4 times 11 is 44. If I take 25 minus 44, I'm going to get a negative 19. So I'm going to have the square root of negative 19. Can't take the square root of a negative, so this would be no solution. That means the graph would not cross the x-axis if I graphed it. All right, last question. If I look at number 10, I notice I have an x term, so I can't use square roots. I don't want to use graphing, so I always want to check factoring, because it is a little faster than quadratic formula. If I can get it to factor, give yourself a minute or so. Let's see. X squared is x times x. What can I multiply to get 35 that adds to 12, a positive 12? Well, 7 times 5 is 35. And the outside would be 5x, the inside would be 7x. That would add to 12x. So I could just factor and then set x plus 7 equal to 0 and x plus 5 equal to 0. If I solve this equation for x by taking away 7, I get x equals negative 7. If I solve the second equation, I would take away 5, and I would get x equals negative 5. So my solution is x equals negative 7 or x equals negative 5. If I use the quadratic formula, I would get the same solution. So hopefully you're feeling good about our objective today to solve the quadratic equation by using the best method. Right. Our assignment today is page 521, numbers 23, 24, 37 to 46 all, and 51 to 52 all. This assignment is on the Big Ideas website. Please email your teacher if you have any questions.